So now that we know we're going to be working with proportions and solving for proportional relationships, we can jump into our first problem. After 2 hours, so I'm going to highlight the important information. So after 2 hours, the air temperature had risen 7 degrees Fahrenheit. At this rate, how long will it take for the temperature to rise an additional 13 degrees Fahrenheit? So that's the important information we extract from the problem. Now, since we are solving proportional relationships, you know that we're going to start with a proportion. A proportion is going to basically be a rate, a ratio, a fraction is equal to another fraction, a rate, or a ratio. Remember that it can be called a rate, a ratio, or a fraction. It means the same thing. So we're going to start off with two fractions, and they're going to be equal to each other. So what we're going to do is we're going to get the information, put it into one fraction, and then get the other information and put it into the other fraction. When we were talking about proportions in lesson 1, I told you that one thing is important. Make sure that whatever category you put on top of one fraction, it must be the same category for the other fraction. So right here, you can see that we're talking about, when I say categories, we have hours, and then we have temperature. So if I want to put hours on top, then make sure that in the other fraction, hours is on top. If you want to put the temperature on top, make sure that in the other fraction, the temperature is on top. Just make sure side by side, they're the same categories. Going with what I taught you, remember I taught you about independent and dependent variables. So usually time is independent. So usually time I'm going to put in the bottom. So I could put hours there. And since I put hours in the bottom there, make sure I put hours in the bottom there. Next thing I have is temperature. So I know I'm going to have degrees Fahrenheit on top. And since I have it on one fraction on top, make sure the other fraction also has it on top. So I'm trying to stick with I'm trying to stick with dependent variables go on top and independent variables go on the bottom. However, to be honest, if you make the mistake and do it the other way around, it's not going to matter. What's important is not what's top and bottom. What's important is side to side is the same information. As long as you have side to side the same information, you will do well on proportions. So in my first setup, I have 2 hours is connected to 7 degrees Fahrenheit. 2 hours, air temperature had risen 7 degrees Fahrenheit. That is attached in one fraction. So since I have temperature on top, I'm putting 7 on top. And since I have hours on the bottom, I'm putting hours on the bottom. So our first sentence gave us our first fraction. Now continue. At this rate, how long will it take for the temperature to rise an additional 13 degrees Fahrenheit? So they gave us another temperature, so that's going to be in the other fraction. And you realize it's asking, how long will it take? That means we don't know. That is my unknown. Whatever is my unknown, I'm going to represent with an X because that's what I'm looking for. So I'm going to put an X there because that's the information they want us to find out. They know that in 2 hours, it raised 7 degrees Fahrenheit. So if it raises 13 degrees Fahrenheit, how many hours did that take? So first process is to set up your proportion. My proportion is set up. Category degrees Fahrenheit is next to categories degrees Fahrenheit. Category hours is next to category hours. So all we have to do now that we have our proportion set up is cross product, cross multiply. So we're going to cross multiply 13 times 2. 13 times 2 gives us 26. And that is going to be equal to, remember both sides have to be equal to each other, 7 times x. And when you have 7 times a variable, you just put them together. That just means 7x. So set up your proportion, cross multiply, and now we have that 26 is equal to 7x. Last step, divide the number that has the variable. The 7 is attached to the variable, so I'm dividing by 7. Whatever you do to one side, do the same thing on the other side. The same numbers cancel out on this side, so you're left with x is equal to, and you're going to divide this. So 26 divided by 7. 7 goes into 26 3 times. That gives us 21. You're going to subtract. That gives you 5. I'm going to add a decimal. Add a 0, bring it down. 7 goes into 50 7 times. That gives me 49. And that gives me a remainder of 1. So this is going to be an approximation. So if I keep on dividing, you're going to keep on going, but that's an approximation. So x is about, this is the symbol for approximately, or about 3.7. So what does 3.7 represents? How long it will take. So it will take about approximately 3.7, and remember that represented hours, for it to raise an additional 13 degrees Fahrenheit. So that is my answer right there. So that is how we use proportions to solve these problems.